You know, it's funny. Have you ever stopped to think about how your internet connection just works all the time? Well, even when things are secretly breaking, there's some invisible magic happening in the background to keep you online. Today, we're going to pull back the curtain and take a look at that magic, which is called network redundancy. Okay, so let's start with a really simple network setup. Your computer needs to talk to the internet, right? And it does that by going through one specific device, its default gateway. A good way to think about it is like it's the only bridge leading out of your town.
Now, you can probably see the problem here. Everything, and I mean everything, is riding on that one single router. So if that bridge goes down, maybe there's a hardware glitch, the power goes out, someone trips over a cable, your connection to the outside world is just gone. It's totally severed.
Yeah, in the world of network design, this is a huge no-no. It's a massive vulnerability, and it doesn't even matter if you have other backup routers ready to go because all of your devices are configured to only talk to that one specific gateway that just failed.
So what's the fix? Well, the solution is actually pretty clever and elegant. Instead of putting all our faith in one physical router, we create a kind of illusion. We make a single virtual ghost router that's secretly being run by a whole group of physical ones. This ghost is what we call a virtual router. Now, it's not a real piece of gear you can touch. It's more like a shared identity that a bunch of routers all agree to use. And this whole concept is really the foundation of what we call first-hop redundancy.
So how does this little magic trick actually work? Well, imagine a busy call center. All the different operators agree to answer calls coming into one main phone number. That's kind of like the virtual IP address. They also all use the same company name when they pick up. That's the virtual MAC address. Every single computer on the network is simply told, hey, send all your stuff to this one number and this one name.
And here's the really important part. From your computer's point of view, it only sees one gateway. It has no idea there are multiple routers behind the scenes. It just sends its data to that one virtual address, and the active physical router in the group picks it up and sends it on its way. Simple as that. Okay, this is where it gets really, really cool. I mean, the entire reason for this setup is to handle failure without anyone noticing. So what happens at that exact moment when the main active router suddenly kicks the bucket? Let me break down how it happens. These routers are constantly sending little hello messages back and forth to each other. Think of it like a digital heartbeat. The second that the standby router stops hearing that heartbeat, it knows the active one is down. And in that instant, it takes over the job.
And just like that, the standby router becomes the new active one. It completely takes on that shared virtual identity. Now, the physical path the data is taking is changed, but because the destination address, that virtual address, never changed for all the computers, nobody notices a thing. There is literally zero disruption. The switch is totally seamless.
Now, this automatic switchover doesn't just happen by accident. It's all carefully managed by a specific set of rules, or what we call a protocol. And for this job, the rulebooks are called first-hop redundancy protocols, or FHRPs for short. You got a few different protocols that can handle this. To really get a handle on it, let's zoom in on one of the most popular ones you'll find out there in the wild. Cisco's Hot Standby Router Protocol, which goes by HSRP. With HSRP, all the routers in a group elect a leader. One becomes the active router, that's the one doing all the heavy lifting. And another one is chosen as the standby, which pretty much just sits there, listens, and stays ready to jump in at a moment's notice. So how do they pick who's in charge? Well, they hold a quick election using something called a priority value. Whichever router has the highest number wins the election and gets to be the active one. But there's a little quirk. By default, once a router wins, it stays the active router, even if a stronger, higher priority one comes back online later. To fix that, you can turn on a feature called preemption. This tells the original, more powerful router to take back control, making sure your best device is always leading the team. But of course, HSRP is just one way to do it. The networking world is full of options, and there are definitely other protocols out there designed to do this exact same job of providing that seamless backup.
For example, you've got fhrp. Its big selling point is that it's an open standard, which means you can use it on gear from pretty much any company, not just Cisco. And then there's GLBP, which is really interesting. It takes things a step further. Instead of having a powerful router just sitting on the sidelines doing nothing, GLBP lets you use all of your routers at the same time, sharing the traffic load. It's not just about backup anymore, it's about being super efficient.
But really, it doesn't matter which one you use, whether it's HSRP, VRRP, or GLBP. When you boil it all down, the final goal is always the same. And that goal is this: to build a network that's so tough, so resilient that one device failing is just
Not a big deal. The network just fixes itself automatically, and from your perspective, sitting at your computer, absolutely nothing went wrong. It just keeps working.
You know, this whole idea of an invisible, automatic safety net is really a cornerstone of our modern digital lives. It's why things like cloud services, data centers, even banking systems are so incredibly reliable. They all have this hidden magic keeping them running, which really makes you wonder, right? Where else is this silent guardian secretly at work, making sure things never fail?